Module 2 is on linear equations. Let's start off with some rules to remember. First off, it doesn't matter which number comes first when we add or multiply numbers. This is the rule of commutativity. In the case of addition, that means that 2 plus 3 is the same as 3 plus 2. Or in multiplication, 4 times 5 is the same as 5 times 4. Another principle we have is that if we are adding or multiplying more than two numbers, it doesn't matter which pair we add or multiply first. This is associativity. So for example, with 2 plus 3 plus 4, it doesn't matter if we add the first two numbers first. 2 plus 3 is 5, and then add the 4, giving us 9. Or if we add the second two numbers first. 2 plus 7 is also 9. Multiplication holds the same way. Multiply the 3 times the 4 first, we get 12 times 5, which is 60. Or if we multiply the 4 times the 5 first, we get 3 times 20, which is still 60. More rules to remember. Distribution. We can share a number that's being multiplied with a sum, or multiplied by a sum. So in this case we have 3 times the quantity x plus 2. We can share it or distribute it with each term inside the parentheses, giving us 3x plus 3 times 2, or 3x plus 6. We can also add or subtract anything we want to one side of an equation, as long as we also do the same thing to the other side of the equation. This is the additive property of equality. In other words, if we have two values that are equal, x and y, we can add anything we want to one side as long as we also do the same thing to the other. And it goes for subtraction too, because subtraction and addition are really the same thing, just going in an opposite direction. Similarly, we have the multiplicative property of equality, or the multiplication property. We can multiply or divide anything except 0 by one side of the equation, as long as we also do the same thing to the other. So if we have x equals y, as long as we have some number that's not 0, we can multiply both sides by that number. Or we can divide both sides by that number. And again, like addition, multiplication and division are really the same operation, just going in opposite directions. So let's look at solving some linear equations. This is, again, this should be review, but just to refresh it, or maybe if you've struggled, this will give you that click that you've been looking for. General strategy for solving. If you have any decimal values, and this is optional, but you can get rid of the decimals by multiplying by some power of 10. For example, if you had 0.6x plus and then a bunch of other stuff, if you multiply both sides by 10, that would turn this 0.6x into a 6x. And many people don't like dealing with decimals, so that'll make that a little easier. Similarly, we can get rid of the fractions by multiplying both sides by the least common denominator. Alright, if you have any distribution to be done, we would do that next. Then we would simplify each side by combining our like terms. Finally, we're going to add or subtract things from both sides in order to get all the x's, or whatever the variable is, onto one side of the equation and get all of your non-x's, usually the constants, the numbers, get those to the other side of the equation. And finally, we will multiply or divide both sides by whatever it takes to get our x completely alone. X or 1x, what I mean by that is if you have 5x, you would divide by 5. If you had x over 2, you would multiply both sides by 2, whatever it takes. And finally, we always want to check our answer. Make sure we haven't made any mistakes. So let's solve some equations. I'm going to go ahead and bring up the next one so I don't run out of room. Negative 6x minus 5 equals 13. We don't have any decimals or fractions to worry about, so we won't worry about those two. Don't have any distribution to worry about. Don't need to simplify either side. So we'll move to getting all of our x's on one side and all of our non-x's on the other. Now this term has an x in it, and it's the only term with an x in it, so we'll just leave it alone on the left side. We do have a constant on the left side though, and we want that to go away. And if we have a negative 5 and we want it to go away, we will add 5 to the left side. And as we found out, it's okay to add 5 to the left side as long as we also add it to the right side. Adding that to the right side, bringing my negative 6x down, I get negative 6x equals 18. At this point, I want to turn this negative 6x into a 1x, or just x. And to do that, I'm going to divide by negative 6. And that gives me x equals negative 3. Looking at our original equation, let's plug the negative 3 in and see if that gives us a true statement. Negative 6 times negative 3 minus 5 equals, maybe, we hope, 13. So 18 minus 5 equals 13, and yes, that is true. So we have found the solution. With our next example, we have fractions, and shouldn't take too much to realize that we have a common denominator here of 6, because that's a number that 2 will go into 6, 6 goes into 6, 3 goes into 6. It's our least common multiple. It gives us the least common denominator. And I'm going to multiply both sides of this equation by 6. And if I've picked the number right and if I do the multiplication right, all my fractions will go away. Now one shortcut, because we're going to just distribute this 6, one shortcut is to multiply each term by 6, and that just takes out the step of distributing the 6 on the left side. So we have 6 times 3x over 2 plus 6 times x over 6 equals negative 5/3 times 6. If it helps you, you can think of all of these 6's as 6 over 1's. If it doesn't, don't worry about it. Now let's do some simplifying. We can divide this 6 by a 2, divide this 2 by a 2, and our goal being getting rid of the denominator on this first term, we've done it. 3 times 3x is 9x. 9x over 1 is just 9x. In our second term, we divide a top and bottom by 6, and we end up with just 1x equals, and on our final term we can divide the top and bottom by 3, and that gives us a negative 10. Alright, Now we have some terms that need to be combined. 9x plus x is 10x. That is equal to negative 10. We've got 10 x's, but we want 1x. So we'll divide both sides by 10. And we get x equals negative 1. We can plug that back into the equation. We get negative 3 halves plus negative 1/6 equals, we hope, negative 5/3. And if we do that math, we'll see that that is true.